This is ACT 212, Architecture and Trustworthy Computing 212. For those of you who's your first TechEd, the way we arrange these session numbers is the first number is the level of the session. The higher the number, the more complex. 200 level sessions are almost all slides. 300 level sessions, you couldn't expect to see some guts of some products or somebody's going to open up Visual Studio. A 400 level session, if they don't have assembly language on the screen, you should complain. I actually manage the architecture and the Azure track. So if you enjoy the content or like it, let me know. If you don't, talk to Dave Glover. But what we want to do today is kind of address this emerging trend that I find when I talk to our ISV partners. And that they're all wondering, how do they cover all these bases, especially Android and iOS, from a single code base, and still get like the Windows platform? Because we're living in a bit of a different world now, as you may have noticed. And some of these things are getting kind of complicated. We're finding a lot of people start charging down the device-specific path. And what you do is you end up painting yourself into a corner with that single app or something, and then you have to rejig everything or completely change your skill set to go down, say, the iOS path or the Windows path. So we've been working on ways to try to develop this architecture that helps you get all of them at once. Okay? And it's going to take some early thinking. You don't want to sit there and start up Visual Studio, get halfway down the Windows, Android, or iOS path, and then decide you want to reach all the different devices. All right? So that's what we're going to talk about. So the what, the why, the what, and the how. Now, this is an architecture session, so we're not going to be talking about too much code, if any. We're going to be talking about the building blocks you need to set up, the services and systems you need to set up, and how you need to lay out your applications and systems so that you can reach all these different devices, okay? So, earlier, I was asking you all these questions to make sure your arms worked. So if you do have questions throughout the session, ask. Right? I've left plenty of time to answer the questions and talk about some of these things, because some of them get a little vague. Some of them get a little bit complicated. Not for you guys, but Okay? So let's talk about the landscape a little bit. These statements are true as of yesterday. Windows is the leading PC, laptop, and netbook OS. Android is the leading tablet OS, and iOS is the leading phone OS. And this is a global average. This isn't per country, because different countries will have slightly different results, right? And I got these from a number of sources: Gartner, IDC, Stats Counter, Global Stats, Net Market Share. But they all agree on this point, that tablet and mobile are going to start leveling out. There won't be a really dramatic leader in those two form factors. It's going to be a three-horse race at this point between Android, Apple, and us. Now with that, a couple things come up, right? If you've gone down the iOS route, that code is pretty much just iOS. If you've gone down the Silverlight route, well, you've kind of run into a dead end. If you've gone down the Android route, you're a little better off, because BlackBerry actually did something I think is very crafty, very, very well done. When they did the new BlackBerry OS and released a new phone, they made it run Java-based apps just like Android apps. So now in their marketplace, it's like an instant marketplace, because people can just take the Android app and deploy it to the BlackBerry marketplace, and it works. That was a very good move on their part. And the reason is, consumers say, that device is awesome. I love it. When we put a Windows phone in people's hands, they love the device. Then they say, how many apps do you have? And they always compare the numbers. So the best response I've heard for this is, well, how many do you need? How many do you use? What apps are on your phone? And it was always funny listening to the Nokia people talk to, we just had our partner conference, APC. And it was interesting listening to them talk about the app marketplace and how this works, because she said, how many do you need? He said, oh, as many as I can get. Fair enough. What else do you like about the iPhone? and he couldn't come up with anything. So he turned around to the lady at the counter and bought a 925, which I thought was great. But, this is what it is, right? We missed the boat on the phone market, in my opinion. Don't tell Steve that. And so iOS took off, but Android is really coming strong. And so in the next few years, it's going to be this shifting leading edge. But the one thing that none of these people say is that PCs, laptops, and netbooks, that will be a Microsoft territory. Nobody sees that changing for at least the next 5 years. So this is about how you can get all of them. And it's basically, it's going to take a minute to sort out how you want to do this and where you start and what you start with. So what's your target audience? Are you targeting business people with line of business apps? How many of you are only doing line of business apps from mobile computing? Okay. How about consumer apps? You're targeting end consumers. It's actually fewer than I thought. Okay. Mobile devices, phones, targeting phones. Okay. And how many of you have started targeting the Xbox yet? Yeah, I thought so. Yeah. So the interesting thing about the Xbox, have you guys heard about the free operating system thing in the Xbox? Yes, some of you? I know at least 2 of you have. Because they've actually written an app they're going to release on Xbox, which is very cool. And you may even see it later. So with the Xbox, this is our target for the living room space. So when you think about our approach, and you guys have probably heard this lots of times now, we're trying to get a similar or a common concept from the phone to the phablet to the tablet to the laptop to the PC to the living room. This way, everything works together, apps are similar, and we can cover this very broad spectrum of users. So what we did with the Xbox One, is there are 3 operating systems on it. The first operating system is it's basically server core with Hyper-V. It's a Hyper-V layer, which runs the other 2 operating systems. There's the Xbox Gaming OS that's dedicated to the gaming side of things, and the other half is the Windows 8 core. So if you think about, if you write an app that runs on Windows 8 and the Windows runtime, that comes through the Windows Store, that's going to be on phablets, tablets, laptops, desktops, and the Xbox. So with one app, you get all those form factors. All right? Now that's not enough, because that doesn't cover the Android or the iOS devices out there. And right now, if you want to potentially reach, some odd number of millions of devices, you need to look at those as well. Especially if you want to look at the phone, right? Now you'll hear a bunch of us say stuff like, well, there's all these goofy stats. If you look at iPhones, over 60% of the apps in the iPhone marketplace are never downloaded. Out of the other 40%, something like, of that 40% chunk, something like, or just over 35% of them are duplicates. Fart apps, flashlight apps, right? So if you're doing something in that market space, you need to be spectacular. Your app has to be spectacular. And near the end of this, I'll tell you about the lifestyle and the different ways you can make your app shine. But in the Windows marketplace right now, you have to be good to be on the top. Think of it as a big fish in a small pond right now. And early adopters, if you want the early mover advantage, the Windows system is where you want to be. Okay? So of these, people are using these devices in different ways. Now you have to think about this. Most of the devices that are handheld now are touch to some degree. That's why we went with the tile interface, because it's easier to hit those targets. But if you're trying to shoehorn a classic VB or classic desktop app into a tablet, phone, or mobile form factor, you're going to have a lot of frustrated customers. So you need to plan out the way you're going to do your UI and architect the UI in a way that fits the form factor of the device. which means you need some kind of adaptive UI. Okay? Now, when you think about how you're going to do this, do you want to target a specific platform and go for depth, or do you want to target everybody and go for breadth? Now, traditionally, targeting one platform has been easier because you can focus on one code base, one structure. You can build an app, deploy it to the marketplace, and get it. But reach has been hard. And it's been hard because we've been trying to pile too much into the client. So, when you're doing your architectures, the first thing you need to remember is make the UI, make the client as minimal as possible. The more stuff you can move off of the client, the more diverse you can make your UI. The faster you can respond to new UIs. All right? So rule number one, keep stuff off the client if you can. That makes this reach part not quite as hard. Okay? Now, let's get into the actual architecture. We'll spend most of our time talking about this. So right now, most people have this kind of an architecture when they've laid out their application, right? You're pretty familiar with the client-server kind of architecture. And chances are, if you're building stuff on a LAN, you've done this. How many people are still building applications like this on a LAN or on a local machine? Oh, good. Only a couple of you? Cool. All right. These things are, we have a long history of these. And if you have line of business applications, or you have applications you've written that are already in situ, you might have this problem. Migrating these applications will take rewriting them. You're not going to be able to forklift a lot of these older applications and drop them on the new form factors. For one, most of the runtimes or code bases you have in these don't exist on the new form factors. And then most of us probably have seen this where we've got a web PC or some kind of tablet or phone in the UI, and the back end is XML text, RDBMS, or some kind of service call. But these have been fairly tightly linked. So when you're designing these things, decouple them. You need to practice decoupling these things and using service interfaces. If you haven't broken these up and decoupled it, and you're deploying these monolithic single DLL, single library type applications, it's going to be very difficult to change. If you're still deploying monolithic applications, you must have been under a rock for the past 5 years. So now we got this middle layer, the logic layer. And this is the most common app deployment we've seen in most business scenarios now, or line of business applications, or a lot of ISV-based applications are this way. So we have this logic layer in here that does validation, business logic. It does a lot of the processing. It'll do back-end processing. It's the guts of what's happening in the app. Now, most of you, I imagine, are doing this, right? Most of you are building 3-tier type applications. Do you have pretty good integration between the two, or have you separated it? Chances are these last two, these bottom two, are on a server somewhere, right? You can even do really good web-based applications this way, which is cool. You know, we like web. But here's the trick. You need to add these two layers into your applications to get this device-independent delivery. The most important one is probably that service layer. What you need to think about doing or building or delivering are really good services. Think about your data, think about your applications, think about your value add as the results of a service. When you have that, when you deliver that really good service layer, the UI is just coding. It's just, smoke and mirrors eventually. So that means if somebody comes up with a new way, a new UI, a new form factor, let's say they have a smoke signal UI, all you have to do is make your smoke signal UI, call your service layer, and then you have all the functionality there. So this is what I meant earlier about keep that stuff, keep the UI as thin as possible. Keep the code, keep the logic back here. All right? Now, these service layers, traditionally they've been WS star. We're now moving more towards a REST-based service architecture. If you look at Windows Azure, for example, almost everything in there you can access through a REST-based UI. Sorry, REST-based web service. That would be very interesting. Now, just out of curiosity, for those of you taking pictures of the slides, you can download them, right? So, there'll be a much better resolution if you download them. So, the other thing is this idea of a data abstraction layer. Now, I've found that the data abstraction layer is something people often overlook. People often will take their code, and they will just, inside the code, they'll do connection string equals blah, and then they'll say, create database connection. No, oops, I'm sorry. And then they'll fire off and bring back data sets or whatever they're going to do with it, depending on what they're calling. But what happens if you decide to go from Oracle to SQL Server? Or you decide to move off of a database altogether and call a third-party service? Now you've got code rewrite. Now you've got things you have to jig around, problems. So think about abstracting your code and the brains of your application from the underlying data format. This data abstraction layer, actually, let me put this next slide up here. We'll talk about the technology alignment, how you build these things. You know what? I'm just going to put these on the screen. All right. This data abstraction layer, think of things like Entity Framework or the WSDL. WSDL is kind of a data abstraction layer itself. But what this allows you to do is your logic layer, the guts of your application, process on objects or classes. They process on things the machine or things the application understands. They're not processing raw data files and tied to a specific format for the data. This way, if you have to call, let's say you're using SQL Server for some of your code, you have to call an external web service for another bit of your code, and then you have to read a flat file for yet another piece of the code. What this does is it means that your data abstraction layer will provide your application objects and classes to work with, and it never has to know where it got the data or what format it came in. I've seen a lot of people that bundle these two layers together. And if they decide to go from one RDMS to another, even like SQL Server to SQL Express or SQL Server to Oracle or Oracle to SQL or something, or to NoSQL, they have to rewrite and redeploy the application. That data abstraction layer prevents that problem. It helps future-proof your application, and I'm all about future-proofing, right? How many of you enjoy working on the last guy's mistakes? Nobody? What a surprise. The more you can future-proof your applications, the less of that occurs, all right? Now the service layer. That service layer is the other bit that you need to get rock solid. Once you do that, not only can your applications work really well in this environment, but you can start renting out your services. So if you are in an ISV situation, or if you develop applications that you may want to offer to third parties, some value-add data assembly or something, that service layer becomes very, very important. It becomes effectively the front end to your application. What a lot of people have done, look at Instagram, Facebook, Twitter, and all the different clients there are for those. While they may produce their own front end, they may produce their own UI, they can actually sell access to the rest of the AI, the rest of the API that they offer. By doing that, it may open up a new revenue stream for you. Okay? But it's important to get your own apps using that service layer. If you don't, one, they'll accuse you of not being open and fair. Two, you won't know how well it works. It's that dog food scenario. Okay? Now, for the UI layer, it's going to be a website or it'll be a device-based app, 9 times out of 10. And if you're using device-based apps, you want to look for these portable class libraries, these PCLs. If you design things into a PCL, Visual Studio can emit it in such a way that you can move it from device to device to device. So if you do have any kind of validation code you need up front, or the minimal amount of code you do need to put in the client device, package it in a portable class library. The service bus, is an Azure-based construct, or you may have an internal service layer, some kind of EAI system in your organization. That's where the service layer comes in. It's going to be on a service bus or some kind of a web service structure. Now, the WS star stuff works fine, and it will continue to work fine in the future, but a lot of people are heading to REST. They're going towards REST. It just seems to be easier to adopt. There are some things, though, that you may need out of the WS star, like some of the WS security features, even though the REST and the OAuth authentication framework are doing a pretty good job of replicating anything you could need in that. And your logic layer, in Azure, we've got worker roles. That's pretty much the logic layer if you're building that. And then these might be virtual machines hosted in some hoster on premises. Or you can look at things like BizTalk, custom code. It's the brains of your application, right? And then the data layer, well, I already talked about DAO. Data layer, blob, SQL database, SQL Server, or Oracle, blah, 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 blah. How many of you have built some applications like this and deployed them into Azure? Cool. So I'm going to tell you a little bit more about the deployment. Now, when you do these deployments, when you break this application up and you're ready to deploy it and get it running, there's several different ways you can chop this thing up, depending on how much you want it to be internal, how much you want it to be cloud, how much you want it exposed to consumers. To get instant breadth, instant reach for all of the devices out there, you build an HTML5 based website. I know you've heard us, not yammer, I'm not going to use that word anymore. I know you've heard us talk about HTML5 for a long time now. And every device out there, every modern device out there has an HTML5 capable web browser on it. So if you start there, start with HTML5, you get instant breadth. Now there's going to be occasions when you want a richer UI or a richer experience where you're going to have to go to the app layers. So the web one can be done on-premises or from the cloud, right? So then we get into devices and on-premises services. You can break it up this way. And a lot of people will do this until they get their on-premises service layers to a point where they can deploy them in the cloud. So when we get into the device ones, you can have those from the service layer down on premises, or you can move just the service layer into the cloud and have everything else on premises. Now, if you do this, this is where you would use something like the Windows Azure Service Bus. And you can have nothing but a front end to handle the incoming requests in Azure and everything else on premises. This is a good way to start out if you're worried about data sovereignty on today, right? Where if you want the capability and the breadth to use Azure, but you don't want to move your data out of country, off-site. Now, one of the benefits that this particular layout gives you is increased security. So if you think about all the unwashed masses of the internet out there, if you offer a service from on-premises, when they come in to get information from that service, or if you're hosting the website, these people are touching your infrastructure. They're touching your web server, they're touching your web application, which means you have a potential high attack surface. Did you guys, most of you are new to TechEd. Several years ago, I did security sessions, and friends of mine like Jesper Johansson did some security sessions. And we talked about this idea of how to get your network hacked in 10 easy steps. What happens is, the bad guys come in and start fiddling on your web servers, and they find a weakness, and it could be in your application code or an unpatched vulnerability, and they get in there and they establish themselves a little bastion attack host on that server. They get it to download code from their FTP server to your server. Then they log in to their code on your server and use that to launch attacks further into your network. And this can be to the point where they not only get past your web server, but they get past your application server, give themselves an admin account, usually on the database server, and then work their way through your reverse proxies. And you get an entire network compromised doing this. If you just take that service layer and move it into Azure, now there's nothing for the bad guys to physically interact with on your IP addresses. If you move these two layers out there, now you get all the protection that we've built into Azure for your applications. Now, we can't fix vulnerable code, but if the server does get compromised, it's not going to escape the virtual machine in Azure. So the more of this you can put in the cloud, the better off your internal infrastructure is. You lower your attack surface, and you decrease your risk. Okay? I'll get that if you want. No. All right. And as you might imagine, you can do these two deployments as well. Now, this manner of deploying these applications gives you a lot of flexibility. There's a lot of stuff you can do with this. So let's say you want to have hosters or move something into the cloud to save money. You can do this by following one of these four over on the right side. And if you've broken it up this way, with that service layer and that data abstraction layer, it doesn't matter where you put things. It doesn't matter if it's on premises or in the cloud or in rack space or in a different cloud. Well, it doesn't matter. A lot of people like this idea because you can also deploy backup solutions in two different data centers. That way you can have some failover in your data abstraction layer so that if one data center gets hit by a meteor, the data abstraction layer will reroute traffic to the other data center. In most cases, a cloud provider will be doing this for you. When you set stuff up as redundant, they'll handle that. If not, it's easy to build into your DAO. Okay? Does anybody here care about high availability? Good plan. All right. So this data abstraction layer, so I talked about the services layer giving you that extra layer of security. The data abstraction layer gives you that extra high availability. So by plugging that in there and having hot sites effectively in multiple data centers, you can instantly get that switching. Now, if you keep this on premises, we've seen situations where right now, Azure is a good example at the moment because there's a different latency involved, right? And when you get into these kind of applications, you have to start thinking about chunky conversations instead of chatty conversations. Because as you move to the cloud, it's not going to be a zero latency. Even with data centers in country, there's going to be some form of latency. And every time you have to make a call to one of those layers that is not in the UI or that's not on premises, it means that you're incurring that latency hit. So try to do fewer calls with larger returns. And depending on the size of the return, I recommend you think about using JSON. A REST-based web service call with a JSON return is very efficient. It's a very small return package. Now, some of you may be using OData. You may have plugged OData into your applications. And there's a point at which OData starts making sense. If you need the extra descriptive information in OData, you'll have to use it, if you need the extra metadata. If you're just returning single records, small sets of records, lists of things, then JSON makes more sense. Because if you look at OData versus JSON, the header in OData and the metadata is about that big. And the payload may be that big. But in JSON, if the payload's that big, the header's that big. So it's a lot more efficient, which means you don't take the network hit as much. So think about using JSON over REST-based web services. Now, my personal favorite is everything in the cloud, simply because then I can deploy it anywhere in the world. I can spread pieces of it around. I can do a web-based app. I can deploy my services on device. So I'm kind of a fan of this one, right? The reason we're looking at the app things and not everything being done from just a website is while HTML5 is good, it's very versatile, it's very functional, you'll run into situations where you just can't do something, right? And if there's some situations, especially in the iOS and the Windows marketplaces, where an app cannot just be a window to a website. It has to provide value-add functionality to be accepted into the marketplace. Android's not quite as tight about that, but if you want to get onto iOS or Windows, you have to consider that. So what you'll see a lot of people doing, Banking apps are famous for this. They'll create an app, they'll add location services to the app, and then they'll add an ATM finder. That is the value add, and then you click to the personal banking, and it's an iframe to the website. But they've done value add. Try to avoid doing that. It's a bit cheesy. So the thing about apps, back in time, we used to say, for us to advertise, we need to put posters up on the saloon wall. Cool. Then we need to get into the broadsheets. Okay. And then it became getting into the catalogs, the JCPenney and Myers type catalogs. Okay. Then it became, we need a radio ad. Right, radio. Oh, now we need a television ad. Cool, television. Oh, but on our television ad, we're going to put our website address because we're cool and advanced. We have a website. Now we have a Facebook page. Right, we have to get on Facebook. Now we need an app. So app they've also become the new advertising medium. And even if you're an ISV or an SI, I didn't ask you which divisions you're in, but I'm assuming you work for one of those organizations or line of business. Apps are seen as advertising mechanisms, so your customers or you're going to have to develop them. So you might get used to the idea of having this web and an app at the same time. Now, back to the HTML5 thing. The reason we recommend HTML5 is because, one, it's instant reach. You get all the devices at once. The second part of it is that to start getting into device-specific applications, you can take your HTML5 website, pretty much repackage it, and deploy it on Windows and Windows Phone as an app. Not an iframe to the website, but repackage the website as an app. Slight oversimplification, but it's pretty much like that. Especially with the new stuff in Visual Studio where you can declare the new web browser control. You can literally copy the deployment folder for your website, add it to the project, point the web browser control to the project, and the whole thing is packaged as an app. Kind of cool, but then you add different functionality. So that's a really quick way to get on the Windows / so that gives you phablet, tablet, laptop, potentially Xbox, and the Windows Phone. But you're thinking, wait a minute, Windows Phone, 7.6% of the market, as of last week, 7.6% of the market. I don't know. Fine, I get that. But if you want computers, where we're talking about laptops, portables, desktops, that's still going to be the vast majority, over 91% of the market for PCs or for enterprise. And a Mac is a PC. And they will run most of these applications, especially since a lot of people are putting Windows on their Mac, which I like. All right, so now we go to the next step. We're going to talk about this architecture, and we're going to get into how you actually get onto the other two platforms very quickly.
Can I ask a question?
You just did. You want to ask another one? Yeah?
Can we go back to the previous slide?
Sure.
So this architect looks good. I have a question regarding the continuous deployment. So if we are doing continuous deployment, let's say we are using MS Build and we use cruise control or things continuously deployed. So is MS Build that setup support something deploying on premises and on cloud together? So let's say if I say, okay, deploy my UI layer on the cloud and deploy my service layer on the cloud and logical layer on premises. So I don't want to do it manually. I want to do it with MS Build and then maybe integrate through cruise control or TeamCity.
Yep.
Is that support there?
Yep, so let me rephrase the question for the recording and see if I got it right. In other words, with this kind of deployment, if you have broken up your architecture into on-premises and cloud, can things like the continuous integration with cruise control and automated builds do deployments to two different places to do your testing? The short answer is yes. The slightly longer answer is yes, with PowerShell and the right scripting components in your CI server. So have any of you heard or seen the Windows Azure pack for Windows Server? Cool. A new thing for most of you. The Windows Azure pack for Windows Server effectively gives you VM-type capability on Windows Server that looks just like Azure. So if you deploy, if you have an idea of having some of it in Azure, some of it on premises, it still looks the same from a deployment angle. Right? So that's one package, and it'll say deploy to cloud, and these are the two endpoints. You can also add PowerShell scripting to say, these sections deploy to my Windows Azure account or my Windows Server, Windows Azure Pack account. These deploy to our standard database servers. So yeah, it's quite doable. And I happen to know some people that you can talk to get that set up for you. Okay? Anything else before we go on? Cool. All right. So here's an example of a deployment that I worked on with a customer that they wanted this scenario. And in fact, they needed it. This particular customer, who shall remain nameless but lives in Canberra, they needed to have a situation or a solution that they can't be seen to exclude any platform, because then they get nasty phone calls. So what they've done is they moved their public-facing website and web services into Azure. And they used Windows Azure Networking with the VPN tunnels to provide access to their service bus and service layer on premises. Because some of those services come from mid-range systems, some of those services come from mainframe systems. And I don't know anybody who's moving mainframe into the cloud yet. Plus, they had a data sovereignty concern, as everybody in Canberra does. So with this kind of layout, you put a public data cache out in the cloud. Latency, it's just a latency mitigation process, right? This way, all the static data, all the information that doesn't change much or that isn't sensitive, isn't classified, blah, 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 you can cache as close to the website as possible. They deploy different apps, including a HTML5 website that accesses the Windows Azure Service Bus. And the Windows Azure Service Bus handles the traffic routing to either the website, directly to the service layer, or integrating with third-party services. So part of the website is a front end to other B2B scenarios for their partner organizations. And it routes traffic to the right one. This isn't, I mean, a year ago, this would have been very difficult to do. Now, with the Azure Service Bus and notification hubs and REST-based web services and better tooling for the apps, this is actually fairly easy to accomplish. This service layer can exist in different places. There's a service layer on premises, and there's a service layer in the cloud. That data abstraction layer, as I showed earlier, it can call services. Data access doesn't have to be just bits and bytes. It can be another service. So you'll see a data abstraction layer called back into the service layer. If you do that, you get a lot of versatility, and you can add third-party services for partner organizations or business to business very quickly. If you have a good service bus up there as the front edge of your service layer, it's just a matter of adding the endpoint. In most cases, it's a matter of adding the endpoint and getting the right data structure out there. So this is the system that they're using now. One of the things that they wanted was this reduced attack surface. That's why they moved as much of the public stuff into the cloud as they could. Because in this case, in Azure, our infrastructure is much better equipped to handle it. So how many of you are worried about DDoS, distributed denial of service attacks? Anybody getting taken down? Have anybody been taken down by one? No? Ah, congratulations. Oh, have you? It sucks, doesn't it? They're hard to defend. So for those of you, does anybody not know what a DDoS is, distributed denial of service? Cool. The thing about a DDoS is that to defend against it, there's three things you have to worry about. CPU starvation, network starvation, or physical access, file access starvation. Most often it's done on a network starvation process. How many of you have pseudo infinite bandwidth in front of your services? Didn't think so. Azure has a lot of bandwidth, which is one of our defenses against DDoS. In fact, out of all the network providers or network capacity holders in the world, we're number 19. The other 19 in the top 20 are telcos. So we have more, I think out of the top 25 or top 30, we have more network capacity than some telcos in the world. So that's hard to choke off. The other aspect is we have very specialized networking hardware, networking software to shunt off and identify DDoS attacks. By putting your service bus or putting your public websites into Azure, you get that protection for free. It's just part of being in Azure. So you get that DDoS protection. You also get the protection of isolation, of having bad guys not be able to escape your shell. So if something happens in another VM and it gets compromised, we squish it, right? So you don't have to worry about cascading effects and shared infrastructure problems. So this is actually the high-level architecture diagram that they base the rest of their systems on. Now, it obviously doesn't include stuff like multiple servers or how many of each or failover or the round robining, but that's the layout, that's the deployment they're using, okay? Now, some of the guidelines. The recommended order that I suggest you do this in is that. Start by building a really good REST-based service layer. This REST-based service layer, you will use it to build your HTML5 website and to build your apps on. You need to use it during your testing and your processing to make sure that it works, right? Especially if you plan in the future to farm this out to somebody else, to rent out your services. Build that HTML5 website. Now, here's where we're going to talk about getting onto their platforms fairly easily. How many of you have actually heard of Xamarin or PhoneGap? Yeah, so those are going to be your best friends in getting this multi-platform device solution set up. And the other one is like the UIs. You've heard of Kendo UI? Kendo UI is pretty slick. It takes your UI and takes your markup, and then it makes it look like the device it's on. Because if you look at an iPhone, it has kind of a specific look and feel, and Android has a similar but different look and feel, and then Windows Phone is quite different, the look and feel of it. But Kendo UI will tweak your app to look right on each platform, so it looks native. This is where we get into this create device-specific UIs to get to platform-specific features. The most obvious example of this is live tiles. And forgive me for I don't do a lot of iPhone or Android development, so I'm not sure if there's specific features they have that other devices don't. But Windows has got the live tiles, right? If you want to take advantage of those, you're going to have to write some device-specific code. But this is the only place you should do that, is for very platform-specific features. If you create a live tile and package it with a generic deployment and spit it out, it's not going to do anything on an iPhone, right? Or if you have an iCloud access, it's not going to do anything on Android or Windows, right? So limit your device-specific code to that, right? Only take advantage of platform-specific features. Now, the thing about the HTML5 is that it's been expanded to where you can do location services with HTML5. You can access the GPS. You can do local storage with it. It has canvas and video capabilities, so you don't need Flash. The way the HTML5 standard came about was the WC3 looked at HTML4. They found out that all the modern web pages were a head and body tag, and everything else was plugins. Flash plugins and Silverlight plugins and blah, 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 blah. So they looked at the top 20 things people were making plugins for, took the top 10 and a couple others, and made that part of the HTML5 standard. Common ones were like video. Now we've got the HTML5 video tag. We've got Canvas, so you can do things that you used to be able to do in Flash. So if you haven't looked at it, go back and take another look at HTML5. And now if you do that again, that website, even if you stop at that second block, you get breadth. You need feature-rich, carry on, okay? So this is the order I kind of recommend you do this in. Now, the guidelines. Have I said limit device-specific code yet? I really want to talk about this one. Follow the flavor of the platform. And I'm going to give you my spiel on platform flavor. And this isn't bagging out other platforms. It's just how I tend to look at things. If you look at an iDevice, an iOS, like an iPad, the way people seem to use iPads is it's like a briefcase. An iPad's like a briefcase. They have a lot of these apps that they have on the iPad, but it's like having a briefcase full of things you use. There's a calculator in there. There's your spreadsheets. There's a notebook in there. There's your emails in there. And when you use it, you look at the iPad, you flip through there, you take the thing out you want to use, you use it, and then you put it back and you get out the next thing and use it, and you put it back and get out the next thing and use it. But it's all kind of jumbled into the briefcase. Let's say you have two newsreaders, because you like two different styles of newsreaders. You pull out one newsreader. Okay, I want to add a news feed, so I go into its settings, and I add a news feed, and I'm done. Then you get out a different newsreader. Wait, the settings for this aren't there. They're actually in the iPad settings. So I go in the iPad, change its settings. So this collection of apps in the briefcase, they don't work the same. And that's an acceptable paradigm on that platform. So if you write for that platform, you can do your own version of settings. You can have your own pretty much anything. Windows is different. The way I look at Windows devices, let's take a Surface or any of the myriad of other Windows tablets out there, it's a lifestyle device. It's a lifestyle choice. And this is particularly important if you're targeting consumers. When you choose a Windows device, you choose one that looks and feels like you want it to be. But all the apps on it add functionality to the device. If you have two different newsreaders and you want to change the settings, you swipe in, you hit settings. Bring up the next one, you swipe in, you hit settings. If you want to share something, doesn't matter what app you have, you bring it up, you swipe in, you hit share. If you want to have two apps on the screen, you pull the slider over, put two up there, you share stuff in between them. But when you add something to it, it surfaces, no pun intended, as an extra feature of the device. And you can use the live tiles. So when you're thinking about doing platform-specific bits, you need to architect it in a way that it fits the way the device is used. If you try to do a live tiley looking thing on an iPad or an iPhone, people are going to go, that doesn't look right. It gives them the creeps, right? Or if you try to make the little rounded box icons on a Windows device, it's going to stick out like a sore thumb, and not in a good way, right? This is where things like Kendo UI are going to be important to use. Even if you don't have a really good use of the live tiles, make your app icon, your app tile, look good. Because we've kind of reserved the formerly known as Metro style of tile icons for us, and it makes sense, it looks nice, right? But if you look at our partner apps and other things that are on the devices, they have, for lack of a better term, sex appeal. They look good, they draw your eye. The ones that are active and show really cool information will bring you back to it. And those are the ones that tend to get pinned to the front of the screen. So when you're planning out the architecture, if you're going to target the Windows platform, which you all in a Microsoft conference, I imagine you will, think about that. That UI, that look, that feel, that plugging into the style of the device is going to be very important. Okay? And here's a trick to getting featured in the stores. If you look at the Apple or Android stores, to get featured in one of those, in some cases it's roll the dice. In other cases, it's you're already on a winning roll. And they'll advertise the fact that they got this winning thing already on the platform. With us, believe it or not, a good chunk of being featured is how good that graphics package looks that you provide us. And I don't tell everybody that. I'm not supposed to tell you stuff, but I've had a couple featured apps that were just kind of, they're okay. But I had a really good background graphic feature, tile looked good, and it looked good on the back of the store, right? So it plays a part into getting featured. Now, each region in the world has some influence over what apps get featured, right? So if you write a really good app, it adds a lot of value to the device, it provides a lot of value to people, we can help feature that app, okay? So, this other thing is this idea of hybrid. Now, that graphic I had up there earlier is a hybrid solution. Part of it's in the cloud, part of it's on premises. And you'll find that for some reason, people have in their minds that cloud is an all or nothing proposition, and it is not. You shouldn't be thinking you're going to move everything to the cloud. That doesn't always make sense. In a lot of cases, you need to keep some things on premises, especially in the realms of confidential data. So think hybrid applications. Now, there's going to be a couple sessions here at TechEd that focus on designing these hybrid applications. The way we kind of laid out the tracks is today is pretty much intro stuff, and the further you go into the week, the more detailed things get, so you can build on the sessions. So you'll see some sessions on how these hybrid applications hang together. You'll find that applications go from being CPU and RAM requirements to being bandwidth requirements, either from within the organization out to the cloud or out to the customers, or from the devices. So think about your being network friendly when you're doing this, chunky versus chatty. And don't forget that your DAOs can point to service layers. That service layer has to be rock solid. Fortunately, when you do a service layer, there's less things to fiddle with, less things to secure than a UI. And if your UI can only be compromised on the system itself, you're much better off. Okay? So, some of the concerns. Latency is going to be a concern, especially in Azure, until the data centers pop up down here. Well, I shouldn't say they'll go away, but we'll have a much better bandwidth scenario. So we've already talked about latency. Now, authentication is the other one. You should be planning and you should be designing for effectively claims-based identity. Claims-based identity is Active Directory Federation Services. It's the SAML or OAuth token trading. How many of you are on Office 365? Okay. You guys are actually already using Active Directory, Windows Azure Active Directory right now. Office 365 bases its identity store in Windows Azure Active Directory. This can also be accomplished using ADFS. So if you use Windows Azure Active Directory, you can sync it with your identity store on premises. Now this makes it a lot easier to do line of business applications that are front-ended in the cloud. Because now they can sign in there with their corporate credentials and have access to your cloud applications and the local applications. Using Windows Azure networking, you can actually effectively create a VPN tunnel. So somebody in Dubbo can log into the Windows Azure cloud-based service, or somebody in Dublin can log into the Windows Azure system over there, and those systems in the authentication framework can tunnel from site to site and site to on-premises in your organization, and we can effectively provide the VPN tunnel. And if you're using Cisco or Juniper Kit, that's a little too detailed for a 200-level talk, but if you're using Cisco or Juniper Kit in your data center, it'll provide the secure VPN entry into Azure. So when you're thinking about authentication, SAML is good, it's accepted, it's well known, but a lot of this is going towards OAuth 2. Do any of you have consumer-facing apps that you want to authenticate with Facebook, Google, Yahoo, anything like that? A couple of you? This is that OAuth scenario. So anytime you see an application that says, would you like to log in with your Facebook credentials? That's OAuth. And you can provide that with the Active Directory, Windows Azure Active Directory, with the access control service component. Okay? Now, the code rewrite. This is a big concern. You may have these historical applications that are monolithic or big or kludged together, and you're going to have to rewrite some code, right? If you've written Silverlight, your XAML experience will carry forward. I wouldn't pursue Silverlight too much further. I think we can officially say, they gave us a phrase to say. It said, pursuing Silverlight is a non-strategic decision. That's the phrase they gave us to say, yeah. So look at that. Now, in most cases, you will still be able to use the existing type of languages you've been using or existing structures. Where you might not is if that technology is going away or if the cloud platform you're deploying to can't support it. Now, we've tried to do a good job in Windows Azure of making it pretty much most code friendly. It does PHP, Java, Ruby, .NET. In fact, there's even a COBOL interpreter you can run in Azure, although I don't know why you'd want to. So maybe we could get mainframe applications in there. Anybody working on AS400? I'm sorry. They're really good, solid machines, but it takes some fiddling to get going right. So, in a lot of cases, when you're ready to do this, you're not just going to go and say, in our next patch, we're changing. You're going to have to do this incrementally. And you may have a case where you take the application running on the servers and you forklift those servers into Azure, or your favorite cloud provider. If you are running Hyper-V and those kind of scenarios in your data center, those VMs can be copied right out into Azure and they'll run, because Azure runs Hyper-V. Right, under the covers it's Hyper-V. If you have VMware images that you want to run in Azure, we have a tool that will translate it into a VHD file and copy it up there for you. We don't have a tool that goes the other way, but VMware probably has one. But that'll help get your applications up and running in the cloud, or the pieces of them you need to get up and running in the cloud fairly quickly. Once you do that, once it's stable, you can start piecemealing the rewrites, right? It's not going to be an overnight process. There may be some pain involved. If there is, well, don't call me, call one of our partners. No, we'll help you. We're producing a lot of guidance in this, so think about that. But it may have to happen. You really can't avoid it entirely. So some of the related content. Got 15 minutes for Q&A. I didn't do too bad. These are the sessions that go a little deeper into like these hybrid applications and how to do cross-device notifications with Xamarin, right? So here's where you're going to start getting into the meat of this and how you're going to take this architecture and take this structure and how you're going to build out the pieces of it. That middle one, AZR316, from Nick Harris, we brought him over for Corp. That may have changed time slots. Please check on the time slots for that. We've had visa issues with one of the speakers, and she's running a little behind. So I think this one is going to be quite valuable for your developers that are going to be creating these multi-platform apps. Okay? And then I got to put this one up here. And also, don't forget that aka.ms/AGT. I think that'll be kind of cool. We're going to be giving away those prizes throughout TechEd, so we may give one away today and a couple tomorrow, and so we'll see what happens. These are the resources for the architecture track. Have a look at some of these. Again, you can download these slides, so you don't worry, I mean, you can take pictures and do it now if you want, but you can download the slides in a little bit. And from that, everybody done taking pictures? It's always easy to see the people with iPads taking pictures. Winoscope mouse. I couldn't even get myself one of these, but hey, wait a minute. That was kind of quick. So do that. Please fill out your evals. If you like this session, my name's Rocky. If you didn't like this session, my name's Jeff. And again, a 200-level session. I know it's a bit high level, trying to cover the bases, and things will get deeper as we go through the week. I usually try to hang out somewhere in our expo center, near the cloud stand or the dev den. If you have questions or you want to get on a whiteboard and hash things out, come down and look me up. We'll do that. My actual job is I'm a technical evangelist for Azure, so I may lean towards the cloud. But if there's any questions, now's the time. Yeah?
I noticed that you talked about REST services
Mm-hmm.
and WS star services.
Yep.
Is it better to have a WCF service so you can expose many endpoints, allowing a wider sort of access from the client?
You mean like having two, having WS star and REST, or just WS star and?
A WCF service gives you REST, WS star, NTCP, MSMQ, pipes.
You can. But what you're going to find if you start doing that is you start getting a lot of different things you have to maintain. Most systems can handle REST, and they'll handle WS star fine. If you diversify too much, it starts getting complicated.
But there are additional endpoints. I mean, your code will remain the same. You will
Yep.
expose different endpoints, which means you can get different message formats.
Yeah, it's not complicated from your side. It's complicated from the other side of the fence. Which one do you call are the different features?
REST. On the other side, I can choose REST, but if I do not want REST, I can choose WS star.
Yeah.
Or say, if I have safe on the other side of the wire.
A web API? Sure, you can do it. Yeah, absolutely. Yep. It'll give you definitely a broad spectrum to hit, but yeah, that's cool. Okay. Yep. Yeah. Yeah. So, but Microsoft SharePoint will never be deployed as an app, right? So when we're talking about the concept of apps and deploying apps to the different devices, phones, tablets, blah, 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 you need a very thin client. If you can write a thick client, or if you're doing a website, well, it's clients as thick as it has to be, right? SharePoint, I mean, it's kind of an apples to oranges comparison if you compare SharePoint to an app or a website deployment itself. So, yeah, I wouldn't use SharePoint as a shining example of how to build an app. What else? Yep.
When you're talking about REST-based services, what level of REST are you really referring to? Are you just talking about more of a URL structure, or are you talking about actually using hypermedia?
Well, what I'm primarily referring to is have a REST-based endpoint. Because of the way the web tends to be going is people are expecting a REST-based API call or REST-based endpoint or REST-based web service. The back end, once you're past that endpoint, the back end can be anything you want. Whatever makes sense to you, whatever you're used to developing, or whatever you may already have. So for me, the REST base is basically the endpoints, the URL structure for endpoints and being able to access it with REST and JSON. Yeah. That make sense?
Yeah, we're talking about slightly different things. So it's more the URL pattern that you're referring to.
Yeah, you could say that. But when you look at the REST-based web services, right? REST is a web service structure. It's a web service pattern, right? So it's the whole blah blah state transfer style. I wouldn't veer too far off of the established REST stack. I suppose you could, because REST is more than just the URL, right? Yeah. Yeah. So I would probably try to stick with the whole REST package, not just have a REST style URL that maps to a different style of service. If it was me. Cool.
Question. You talked about Silverlight being phased down. What's going to replace it? I mean, HTML has not quite lived up to the hype, and we still need a rich internet experience. And Silverlight is great because the XAML and the data bindings are quite good, really.
Yeah,
What's
so
going to replace that?
what's going to replace it eventually will be the HTML5 ratified standard. So the standard for HTML5 hasn't even been ratified yet. It's still emerging. They're still fixing the quirks and the tweaks. Once it's there, it'll be good. It'll be rich, and you'll still have AJAX style for the RIA style systems.
Yeah, we look at the data binding and the MVVM type of architectures coming in.
Well, you still have that, right? If you build, let's say you're doing an MVC application, or you're using Razor syntax and ASP.NET, you still have data binding on your controls. You still have data binding on lists and text boxes and labels and everything else, and it's built in, right? So that exists now. If you start a new ASP.NET website and you've selected Razor syntax, you get all that.
That's if you use web forms, but if you don't want to use web forms, then go back to, say, MVC, you use native HTML.
You can. I mean, that's kind of, I don't know if you'd want to go backwards that much.
But why are you facing off Silverlight? I mean, it seems to be technology.
Well, so us and Adobe are doing that with Silverlight and Flash, right? Because the primary functionality that Silverlight delivered was video streaming and then the ability to do XAML-based markup and sexy interfaces. You can pretty much do that with the HTML5 video tag and the canvas tag in HTML5. You can pretty much replicate anything you can do with Flash or Silverlight can be replicated in HTML5. So we've taken the decision that where a standard exists to do something, we will adopt the standard. If a standard does not exist, we will work with ISO and Apple and Google and everybody to create a standard for it. But we're trying to really get away from this idea of proprietary stuff. I mean, it makes things too hard, especially in this world where devices are going to be different. You don't want to distribute plugins. If you look at Android devices or something, they have trouble with adopting a Silverlight plugin, you know. So we're trying to get away from that, basically. That's why.
You see the focus on native apps phasing off?
Not necessarily. Native apps are going to have their place. It's not so easy to do in a mobile world with Atom processors and really lightweight devices. You still be able to do native apps on Windows 8 based devices, but if it's an RT, a tablet, a phone, they can't really run them anyway. So if it's fit for purpose, sure, you could even, I wouldn't write it in VB6, but you could write it in VB.NET, do a WinForms-based app, absolutely. Yeah. Anything else? Yeah. Ooh, a little louder. The HTML5 path? They kind of have. Is this machine on the internet? Let me show you. Oops. I'll see if I can show it to you right now. Wow. Home keys, home keys. So if you log into live.com, and anybody can do this, yes, that's a throwback from my previous days. Oh, I thought he did. Oh, right. I'm going to cheat. You'll have to fix this when I'm done, okay? Because I can't do that very well. At Hotomail. Okay. I'll show you how the Office apps are doing this. I get into here, logged in. I can do Outlook.com. This is HTML5. So the functionality in here, how it works, the new mail, this is all HTML5, right? Now that I'm signed in, if I go to, always make sure there's nothing too objective in your SkyDrive when you do demonstrations. Create Excel workbook. Yep, I probably have 15 book ones in my SkyDrive now. When this comes up, it's break time, right? Everybody's using the internet. Maybe I already have one. Yeah, let's open this. So if I open up Excel, the web-based version of Excel, this is also an HTML5. Now the local apps, the Office 2013 type install, that's obviously not HTML5. There's a lot of built-in code, a lot of stuff behind the scenes. It's a little richer experience. But even in this one, like I've already obviously done this demo in this section before, that is, I can do formulas, so I can do this equals that plus that, hit enter, some number, some other number, right? I have formula functionality, I have limited formatting functionality, but this is all an HTML5 app. So you can see that you can get quite rich UIs out of HTML5 now. And think about Silverlight or Flash, you can't even do this, right? I suppose you could. That would be a pain. But yeah, so we're really getting behind that idea of HTML5 because, again, once you write an HTML5 app, every browser understands it now. So every device gets it. Even though this standard's not quite ratified, when it is, Silverlight and Flash, you really won't need them.